Welcome to The Explainer! I am absolutely thrilled you're here today. If you've been banging your head against the wall, trying to scale up your data collection without having to write complex code, you are in exactly the right place. We're going to explore how to set up an airtight extraction operation from the ground up, making sure you have the exact infrastructure you need to pull it off.
It's the million-dollar question, isn't it? How do you scrape massive amounts of web data at scale without writing a single line of code? This is a huge bottleneck for so many businesses today. You know you need data to monitor competitors, track pricing, or maybe generate leads, but you just don't have the developer skills to build custom scraping scripts from scratch. Or, honestly, maybe you just want a faster, more accessible way for your whole team to pull insights without constantly waiting on the engineering department.
Okay, let's take a quick look at our roadmap. We'll start by meeting Octoparse, jump into why you absolutely need proxies, cover choosing your proxy type, walk through setup and configuration, compare some alternatives, and finish up with scraping best practices.
All right, Section 1, meet Octoparse, the ultimate no-code scraper.
So what is it? Octoparse is a no-code web scraping platform that lets you extract structured data using a totally visual interface instead of programming. Think of it like this. It empowers literally anyone to build a scraping workflow just by pointing and clicking on the information they want to collect from a web page. Instead of writing complex Python or JavaScript, you visually interact with the site, and the software works its magic in the background to build the extraction logic. It even features a cloud-based option, meaning you can let your jobs run continuously without having to keep your own computer turned on.
People use this for a massive variety of data gathering. We're talking product catalogs, price monitoring, lead generation, and grabbing contact info. It's great for real estate and job listings, scraping public business directories, or pulling in financial data for deep market research. Once you collect it, all of this nicely structured data is perfectly prepped and ready to be dumped right into your spreadsheets, databases, or business intelligence tools.
Which brings us to Section 2, why you need proxies, the agitation of blocks and limits.
Picture this. You've built your beautiful visual scraper. You hit run and you hit a brick wall. Websites are smart these days. They easily detect repeated requests coming from a single IP address. The second they spot unusual traffic, they're going to halt your extraction with a CAPTCHA. You know, those annoying security challenges designed to stop bots. And if it's not a CAPTCHA, they might just outright block your IP, throttle your requests, or feed you incomplete data. Without a workaround, your large-scale project is essentially dead in the water.
Enter the ultimate solution, the digital disguise. By using rotating proxies, you distribute your web requests across multiple different IP addresses. This makes your scraping activity look way more like normal user traffic coming from all over the place. It effectively creates a digital mask that prevents those annoying interruptions. For any serious scraping project, proxies aren't just a luxury, they are absolutely essential for maintaining reliability. Moving right along to Section 3, choosing your proxy type, matching infrastructure to your target. You've basically got three main flavors to choose from here. First up, residential proxies. Because these requests come from real residential IP addresses, like the Wi-Fi at your house, they are incredibly difficult for websites to detect. They're your best bet for large-scale scraping against heavy anti-bot websites. Then you have ISP proxies, which are fantastic if you need super stable, long sessions, but still need a high level of trust. And finally, data center proxies. While these are a bit easier for a site to flag, they are crazy fast and cost-effective, making them perfect for simpler sites where raw speed is your main goal.
All right, Section 4, setup and configuration, connecting these proxies to Octoparse.
Hooking these tools together is surprisingly easy. You just open your scraping task and head over to the task settings. From there, select the proxy configuration section, choose your protocol, usually HTTP or SOCKS 5, and drop in the proxy credentials provided by your network. Hit save, run a quick test, and you are good to go. The really brilliant part is that if you're using rotating proxies, every single request your scraper makes can automatically swap to a new IP address. It drastically reduces your chances of getting caught without you having to lift a finger.
Let's look at Section 5, comparing the alternatives, Octoparse versus the rest of the market.
First, let's stack Octoparse up against its closest visual competitor, ParseHub. Now, both of these are excellent, cloud-capable, and incredibly beginner-friendly. But Octoparse generally wins out on overall ease of use. It boasts a much easier learning curve and handles complex dynamic websites exceptionally well. ParseHub is still a fantastic tool, especially for folks who need slightly more customization for tricky workflows, but for pure out-of-the-box accessibility, Octoparse usually takes the cake.
But what if we step outside the no-code bubble? This is where developer-focused frameworks like Puppeteer and Playwright come into the conversation. Puppeteer is built strictly for JavaScript automation and developer scripts. Playwright goes a step further, focusing on advanced browser automation and giving you complete coding control. But keep in mind, unlike Octoparse's visual workflow, you actually have to know how to program to use these.
So it all boils down to one simple choice: no code versus code. Octoparse is, without a doubt, the fastest way to build scraping workflows if you don't have a background in programming. On the flip side, Puppeteer and Playwright offer absolute, granular control over exactly how the browser behaves, but you have to write the code yourself. It's that classic trade-off: speed and accessibility versus total technical control.
Finally, Section 6, Scraping Best Practices, Avoiding Errors and Maximizing Success.
Let's troubleshoot the two biggest headaches you'll likely run into. First, IP blocks. These happen when a site spots your automated traffic. The fix? Rotate your IP addresses regularly using your proxies, and strictly respect the website's crawl delays. Give the site breathing room. The second issue is dynamic content. This is when a site loads its data using JavaScript after the page initially opens. To fix this, you just need to enable browser rendering in your scraper or add a brief command to wait for those specific elements to load up before you try to pull the data.
To bring it all home, let's rapid-fire some pro tips for absolute scraping success. Always rotate your IPs. Randomize your requesting timing. Seriously, don't act like a predictable robot. Avoid blasting a site with too many simultaneous requests. Respect the rate limits. Make sure you test your workflows on a small scale before launching a massive job. And finally, keep a close eye on your failed requests and retries so you can catch bugs early on.
We've covered the whole shebang: the tool, the vital proxy infrastructure, the setup, and the best practices to keep you in the clear. So I'll leave you with this. What valuable data are you going to extract now that you have the right no-code tools and proxy setup to scale seamlessly? The web is absolutely packed with insights waiting to be captured, and you now have the exact blueprint to go out and get them. Thanks for hanging out with me on this explainer, and happy scraping.